functions. Okay, so if I'm looking at exponential functions, to be an exponential function, it has to be in the form y equals ab to the x power. It's only exponential if your x is your exponent.
Now, that one was just y equals 8. I think that was it. And then y.
Okay, so if I looked at example 1a, y equals 2 times 3 to the x power. Because of this x is in your exponent, it is exponential. And we're asked to find when x equals 5, so I'm going to plug in 5 for x. So I get y equals 2 times 3 to the 5th. No, we work backwards. So 3 to the 5th. What's 3 to the 5th power?
No, 3 times 5 is 15. Times 5 equals.
3 times 3 times 3. Use your caret key on your calculator, guys. Remember, you can do any exponent using this caret key. 243. Okay. So 2 times 243. What's 2 times 243?
286. Or 40.
486. Very good. That's your answer.
Oh, wow. You don't need to explain anymore.
Well, easy.
I'll do one more, and then we can.
Do another example.
Okay.
Because you know I wasn't here.
I wasn't here. I did my work yesterday. I didn't ask.
Alright, so y equals 1500 times 0.995 to the x power. This x makes it exponential, so we're going to plug in 8. So 1500 times 0.995 to the 8th power. Yep, so work backwards. What's 0.995 to the 8th power?
0.9609.
9606. I'll just round it off. 960. Okay, and what's 1500 then times 0.9606?
One. You already know the answer. 148. 23.
Okay, so 1488.93. Okay, so that's the first part of what you're going to do is been evaluating exponential functions. You are graphing. The second part of what you're trying to do is you're going to determine if a function is exponential by using the same criteria that you use for geometric sequences. So we're going to ignore our x's because we don't care about those, we only care about our y's. So if I look at my y's, I need to figure out what I do to get from 1.5 to 3. Using multiplication or division.
Multiply by 2.
Multiply by 2 and 3 to 6. Okay, are these all the same?
Yes.
So what's the base?
So then it's exponential. Yep, today's 23rd. Okay, so if they're all the same, it's exponential. Yep.
And we don't have to graph it?
Not on this part. Alright. If I look at example 2b, what do I need to multiply by to get from negative 9 to positive 9? Times negative 1. What do I have to get from 9 to 27? And from 27 to 45? Because these are not the same, you don't even have to worry about the last one. It's not exponential. Your numbers all have to be the same. Alright, the last part of what you're doing is graphing. So we're going to use table of values. Yes, and we're going to use negative 1, 0, and 1. Exactly, Kalani. Okay, so they're always going to be the x values that you use. So if I plug in negative 1, I get 3 times 4 to the negative 1. In your calculator, I want you to put in 4 to the negative 1, and then take it times 3. 0.75. Okay, if I do 0, 3 times 4 to the 0.
Would it be 3?
It would be 3, very good. And 3 times 4 to the first. 12. Okay, so if I graph this negative 1, 0.75 is back 1, up a little bit less than 1. 0, 3 is over 0, up 3. And 112 is over 1, up 12, so way up there. If I then connect my points, I get something that looks like this, and then you just keep going, and so it's going to look like a curve like that. It's not going to be like a U, no. It's going to be like, it's always going to look like some type of curve in that form of a shape. So make it curved.
So like,
They're always curved. If it's straight, then it's a linear function. It's not exponential.
And there's none like that?
Mm-mm.
so they're
They'll always be curved. They'll always have this type of shape. Sometimes they might be like upside down, so they might look like that if they're negative exponential functions, or they'll look like this. But they'll always have like that kind of half U shape. Make sense?
So they're only like 2 or 3. They're only 2
or 3, 4.
Yeah, they're like 2 days ahead of you right now. Yeah. Okay, so if I look at example 4, negative 5 times 2 to the x exponent, negative 1, 0, and 1. So negative 5 times 2 to the negative 1. Work backwards. What's 2 to the negative 1? Nope. Nope, gotta do the 2 to the negative 1 first. Ah, what did I do?
What you do?
I don't know. Go back. Okay.
I had a 0.5.
0.5 and 0.5 times negative 5 is 0.5 times negative 5. Come on, guys, you have a calculator. Negative 2.5. Okay. Alright, if I plug in 0, I get negative 5 times 2 to the 0. Negative 5. And if I plug in 1, negative 5 times 2 to the first. Negative 10. Very good. So if I graph these, negative 1, negative 2.5, so back 1, down 2.5. 0, negative 5, so over 0, down 5. And 1, negative 10, so over 1, down 10. Now I said that they would sometimes be shaped like this when they're negatives. So that one is shaped, it's still U, but it's like an upside down curve, half a curve. You can, it is not straight, because that would be a linear function, and these are exponential functions.
Will I get it wrong?
Yes. Okay. Alright, you guys want to graph one more?
No.
Sure? Okay, we'll do one more. 629. Alright, so if I plug in negative 1, 3 times 1/2 to the negative 1. What's 1/2 to the negative 1? Well, 1/2 is like 0.5, so you can put it in your calculator as 0.5 to the negative 1. Okay, and 2 times 3 is 6. If I plug in 0, 3 times 1/2 to the 0, 1/2 to the 0 is 1. 1 times 3 is, so you remember anything to a 0, exponent is 1. And 3 times 1/2 to the first. 1.5. Okay, so negative 1/6 is back 1, up 6. 0, 3 is over 0, up 3. And 1.5 is over 1, up 1.5. So we can see, oh, that's not a very good line at all. That's really terrible, not at all connected. We'll try going down. Nope, that really didn't work very well either. But you get the point of what it kind of looks like. Apparently not very good at connecting the dots today. There, that's a little better. Okay, so that's what you guys are working on today. 629, 1 through 17.